I'm now going to begin the lectures on Part C of Chapter 9. In Section 9.7, we learn about factors of muscle contraction. The force of a muscle contraction depends on the number of cross bridges attached, and that is affected by 4 factors. One is the number of muscle fibers stimulated, that's called recruitment. The more units, motor units recruited, the greater the force. So the number of muscle fibers stimulated, the relative size of the fibers. There are larger muscle fibers and smaller muscle fibers. By working your muscles and exercising, you can actually increase the size of your muscles. And when they increase in size, we call that hypertrophy instead of atrophy. The more frequent the stimulations are, the higher the frequency of stimulation, the greater the force. That's when we have twitches added together. The degree of muscle stretch. Muscle fibers with sarcomeres that are 80 to 120% their normal resting length generate more force. So if the sarcomere is less than 80% of its resting length, the filaments overlap too much and force decreases. If the sarcomere is stretched more than 120% of its resting length, filaments don't overlap at all, so force or don't overlap enough, so force decreases. That's something that's easier to show you in a picture. So these are the 4 factors that increase the force of skeletal muscle contraction. High frequency of stimulation, large number of muscle fibers recruited, muscle fibers that are actually large, they have hypertrophied. You can see these 2 are much larger than this one. And muscle and sarcomere stretch, somewhere in between 80 and 120%. And all of these factors will increase the force of the contraction. So this is talking about the sarcomere stretch. When the sarcomere is shortened to like less than 80%, in other words, to about 75% or less of its normal length, then there's too much overlap. And so it's kind of like if you've already contracted the muscle, it's hard to, you've got to have some stretch in order to have a contraction, right? So if it's already almost contracted, you don't really have a lot of room to move it and make it shorter. It's got to be stretched like here. This is resting length. If you don't have this resting length, this is 100% resting length between the actin filaments. If you don't have this resting length, how can you have it get shorter if it's already too short? Like over here, you've already got actin already shortened, already, overlapping other actin filaments. And here you don't have that. So the only way you can overlap them is to have them not overlapped to start with. I hope that makes sense. And if there's too much stretch, there's nowhere for this myosin to attach to the actin. There's only these couple of places for the myosin to attach to the actin. So you're only going to have so much of a contraction. We want as many of these myosin heads attached to the actin as possible. And there's only 2 on each end that can reach the actin. So too much stretch is not good, and too short is not good. Now, another thing is muscle fiber type, load, and recruitment that is going to affect a contraction. There are different type of muscle fibers, which we call slow and fast fibers. And oxidative fibers use the aerobic pathways of producing ATP, and glycolytic fibers use the anaerobic glycolysis and lactic acid fermentation. So these are the 3 basic muscle fibers. There's the slow oxidative fibers. the fast oxidative fibers or the fast glycolytic fibers. And most muscles contain a mixture of fiber types. So that results in a range of contractile speed and fatigue resistance. In one motor unit, all the fibers are the same type, but you have different motor units that act together. So genetics dictate the individual's percentage of each. So if you have a higher number of fast oxidative fibers, then you're going to have, you're going to be built more for, I don't know, if we're looking at long distance versus short bursts of speed, you know, the runners the runners on the track team that do the short distance running, you know, they have to have a short burst of speed. So they need more fast fibers, but the runners that do the long distance cross country running or long distance running have to have more slow fibers. They need to have more endurance. So different muscle types are suited better for different jobs. The slow oxidative fibers are suited for low intensity endurance activities. For example, maintaining posture. That's not a real high intensity thing to stand upright or sit upright. Fast oxidative fibers are for sprinting or even walking. They're for medium intensity activities. And fast glycolytic fibers are for short-term, intense, or powerful movements, like hitting a baseball. You need a lot of power, but it's a very short-term movement. All right, so So what affects the velocity or speed of the contraction is the predominance of fast glycolytic fibers. And what affects the contractile duration, there's going to be more duration, more endurance with more slow oxidative fibers. I'm just skipping on to where I see areas that I noticed on the exam. So endurance exercise examples would be jogging, swimming, biking. What does this do for us, endurance exercising? It increases our number of muscle capillaries. So it increases the oxygen that gets to our muscles. It increases circulation in our muscles. It increases the number of mitochondria in our muscles, which means that we're going to produce more ATP. That's going to increase our metabolism right there. More mitochondria, you're producing more ATP. That means you're breaking down more sugar. Myoglobin synthesis, and remember, myoglobin is the molecule that stores oxygen in muscle tissue. And anaerobic or endurance exercise, I'm sorry, I said that wrong. Aerobic exercise or endurance exercise results in greater endurance, strength, and resistance to fatigue. And it may convert some fast fibers into fast glycolytic fibers into fast oxidative fibers. Okay, resistance exercise is typically anaerobic, so that would be such as weightlifting, and this leads to muscle hypertrophy, or the growth of your muscle fibers. The increase in size of your muscle fibers makes your muscles bigger. Leads to increased mitochondria, increased myofilaments, increased glycogen stores, and connective tissue, and increased muscle strength and size. All right, then there's this section on smooth muscle, which I know there's not a lot of questions about smooth muscle, so I don't want to waste. Okay.